Hello students, how are you? Fine? Good. Today also I am coming to you with a new video. Today's discussion will be basically from optics. We are going to discuss the trajectory of rays when it enters into a medium of variable refractive index. Okay, how can we apply the Snell's law and all? Okay, obviously the problems will be of the advanced and main standard, and I'm sure today also you are going to note all these things whatever discussed in the board, and like obedient students you are going to submit it back to me also. And as you know, my WhatsApp number is there, and you definitely will submit me back. And one more thing, students, you people please always now you keep on your hard work. Okay, competition is not about how much you score in the exam, but remember it is just about how much you go ahead of others in the race. Okay, remember your competitors are studying at this moment, they are really working hard, so you have to even work harder. Okay, I'm sure you will be working harder and harder, and obviously winning the race. Okay guys, today we are going to discuss problems from variable refractive index. Okay, variable refractive index. This is from optics now, of class 12. Okay, whatever notes you may prepare, you submit at that WhatsApp number. Okay, good. Say one situation is there. This is the medium, say this is the origin of the axis, this is x-axis, this is y-axis. Okay, say the refractive index of the medium, say going on increasing along y, going on changing along y according to the relation, say mu equal to something y to the power 3 by 2 plus 1 under root. Okay, it is changing like that. Then one more data is given here. A ray is incident at this origin. Okay, let us write mu here. Mu is equal under root y to the power 3 by 2 plus 1. You can take any expression, no problem. Just understand the fact. Say one ray is incident at this point. Okay, this is the incident angle, and say incident angle is 90 degree. Okay, say incident angle is 90 degree, that is given. It means grazing incidence at this origin. The eye is 90 degree, it means it is grazing incidence. So what will happen? Due to the variable refractive index, the ray will follow some different path, it will not be straight. So what you need to do, and this side is also air, and here also air. Okay, first question, you please write down the question first. You have to obtain a relation, between slope of the trajectory of the ray at any point on its path. Okay, say this is the point B. At any point B whose coordinate is xy, okay, in the medium, and the incident angle at that point. And what will be the incident angle at that point? Say this is the incident angle. Okay, we have to draw normal also. So this is the incident angle, and the incident angle at that point. Okay, so I need to find out the slope here and the incident angle here, so that way we have to make a relation between them. And second part, obtain the equation of trajectory. What will be the equation of trajectory? We need to find out. Obtain the equation of trajectory of the ray. Okay, good. And third question, say what will be the coordinate of the point from where ray will go out of the medium. Okay, find the coordinate of the point, say P, say this point is P, from which ray comes out of the medium. Okay, and 3, you can you may be asked what is the angle of emergence. Okay, say this is the angle, so what will be the angle of emergence? Say this way it goes out. Okay, so you need to find out the angle of emergence also. Find the angle of emergence. Okay, it is a very good question. We have to calculate all these things very smoothly, no need to worry. I hope you have copied all these things, because I need some space. I have to rub it. Okay, and what they are asking, see, this is a medium whose refractive index gradually changing along y. Okay, a ray is incident at angle 90 degree, means grazing incidence at the origin. So as the ray passes through the medium, I need to find at any point B in the ray, I need to find the relation between slope at this point and angle of incidence at that point. Okay, then I need to find out the trajectory, equation of trajectory, okay, of the part, and also I need to find from which point it emerges to the air. Okay, emerging out of the medium. Also find that emerging angle. Good. These 4 equations are there. If you want, you can give a pause to the video and you please try before I do, but I have to do, so that's why I am not wasting any time, and let me do it first. Okay, good. Questions are remembered, so no problem. 2 basic data is very important. Two basic data, that mu and incident angle. Okay, good. Say this is the medium, this is the origin, the ray is going, say, this way. Okay, so this is a point at any moment. Okay, let me draw the slope here, slope. So this is the slope. Okay, this is, say, theta, tan theta is the slope at this point. Okay, and you have to draw one normal, because you see layer by layer refractive index is increasing, na? So say this is the normal. So this angle is incident angle at that point. Okay, this angle is incident angle at this point. Okay, great. So what I can see here, at this point slope is dy by dx, because I have assumed that this is y-axis, this is x-axis. So dy by dx is nothing but the slope. So dy by dx is nothing but tan theta. Okay, but I know that theta is nothing but 90 minus I, because it will be 90 degree. No? This will be 90 degree. So it can be written as tan 90 minus I. Okay, so finally dy upon dx equal to tan 90 minus I is what? Cot I. Okay, so first answer is found out. Now the second part, I need to write the equation of trajectory of the ray inside the medium. Okay, good. For the second question, what I can do, first part is done, na? So for the second part, from here only we can start, because you see dy by dx now I can integrate to get y and x also. Okay. You see, if you apply Snell's law here, okay, if you apply Snell's law between this and this, from Snell's law, what I am going to get? See, Snell's law is mu1 sin theta 1 equals mu2 sin theta 2. Everybody know. So mu1 is 1 here. Medium, it is air, na? So refractive index is 1. And this is sine. Incident angle is said 90 degree. Na? That is given. Okay, good. And mu2 at this point mu2 is mu. And the sin theta is I. I have taken I. Na? Good. So from this I can get sin mu, sin I equal to sin I equals 1 upon mu. Okay, good. So from that I can find cos I is equal under root 1 minus 1 upon mu square. Okay, what I am calculating cos I, because sin I upon cos I is tan I, from I, it will be of help at this. So now again what I am getting? I am getting here dy upon dx equal cot I. Cot I means cos I upon sin I. Okay, so dy upon dx, dy upon dx. Okay, dy upon dx equals, what is cos I there? Cos I is under root 1 minus 1 by mu square. What is sin I? 1 by mu. Okay, good. I need some space. I have to write that part. I have to rub this part. I hope you people have already copied it. Otherwise rewind it and copy. So what I am getting here, dy upon dx is equal, that it can be written as mu square minus 1 under root upon mu by 1 by mu. Okay, so after putting this, mu got cancelled. Dy upon dx equal under root mu square minus 1, and you know the value of mu also. Dy upon dx is equal, if you square it, so you are going to get 1 y3 by 2 plus 1 and minus 1. This minus 1 is for this. Okay, 1 cancelled. So it means you are going to get dy upon dx as, what you are going to get? Under root of, means y to the power 3 by 4. Okay, I hope you are getting up till now. Okay, now it is becoming very easy to integrate all these things, you know. Okay, you please do before I complete it. It will be dy upon y to the power 3 by 4 equal dx. Okay, let me rub this part. So integration of dy upon y to the power 3 by 2 and integration dx. Okay, good. And it is origin, because ray is passing through the origin, na? So when x is 0, so y was also 0. When x is x, I don't know what is the value of y, so that is why I am putting y there. Okay guys, what it will be? Integration of this thing, na? Do it, solve it before I do. You just complete it. After solving it directly, I am writing the answer. After integration, you can find out y to the power 1 by 4 equal 1 by 4x. Okay, 4x, 4y. So that is why you are going to get the final expression is of this is the expression only. Final expression, the relation between y and x. It is called equation of trajectory only, nothing else. And as you got the trajectory, now you can calculate the other things very easily. You see at p, okay, this value is not given. I have to give this value also. Say this is 1 meter. Total thickness is 1 meter. That is I left to give you. So at p, y equal to 1 meter. Okay. So what will be x? Put the value of x. X equal to 4. Y to the power 4. Put the value of y 1 meter. So x equal to 4. It means coordinate of p point. Coordinate of p point is 4, 1. Okay, good. And last question is what is the angle of emergence? So you apply Snell's law between this and this. Okay, here also it is here, as you understand, mu1 sin theta 1 equal mu2 sin theta 2. Okay, mu1 is 1, sin theta 1 is 90 degree, that is 90 degree given, and mu2 again 1 air, then we need to know E value. So again you are going to get E equal to 90 degree. It means it will emerge, it will show grazing emergence at the point P. Okay, at the point P it will show grazing emergence. So that way you can do this type of problems, and for you I am giving you a homework. Okay, you can do it, no problem. Just I am changing the function y, nothing else. Other things will be remaining almost same. So just you can do it, I am sure you will do it. Okay guys, just copy it. Say other conditions almost remain same. What I am giving, say this is 2 meter. Okay, now the function is mu is changing according to the relation under root 1 plus y. Okay, other question is same. Okay, you please solve it and submit me in the WhatsApp. Okay guys, so that way you can do problems. Thank you guys, see you in the next video.